Here f can be taken as, suppose it is uh, polynomial in x. So this f, suppose this is a polynomial in x, then this can be written as a x to the power 6, sorry, here will be 6, plus b x to the power 5 plus c x to the power 4 plus d x to the power 3 plus e x to the power 2 plus g x plus h. Okay, and here in the question you see that at most 6. This means that the coefficient of highest degree term, that is a, may be 0. Okay, and now we see the options one by one. So f1 by 2 will be a 1 by 2 to the power 6 plus b 1 by 2 to the power 5 plus c 1 by 2 to the power 4 plus d 1 by 2 to the power 3 plus, here I write down, plus e 1 by 2 to the power 2 plus g into 1 by 2 plus h. Okay, and here it is given that this is not a rational number, so accordingly here I write not equal to a rational number. Since it is not a rational number, okay, rational number, it should not be a rational number, but here it is given that 0 polynomial v has 0 polynomial, so any subspace of v should contain 0 polynomial, and this will be 0. You see, I show you again. This is a member of v, vector space v, and this will be 0 only when a equals to b equals to c, d, e, g, h is 0. But if you put these values in this equation, then you will get 0 not equal to rational number, but this is false. So a is not our option. Now we go for option B. Let us check option B now. And for that, in option B, we take f to be same. I mean f equals to fx, and the same ax to the power 6, b x to the power 5, c x to the power 4, d x to the power 3, c x to the power 2, sorry, not c, e x to the power 2, and thereafter g x plus h. Okay, and here option B, you have to take 1 by 2 at the place of x. So this will be a 1 by 2 to the power 6 plus b 1 by 2 to the power 5 plus c 1 by 2 to the power 4 plus d 1 by 2 to the power 3 plus e 1 by 2 to the power 2 plus g 1 by 2 plus h. Okay, and this here you see this equals to 1. So 1. Now again using the same logic, I mean here you see for the vector space V, uh, it it has zero polynomial. It means that if you equate this to 0, then it means that a b c d, this a b c d e f g h all will be equal to 0, and you know 0 must be a member of each subspace. So those value, I mean a equals to 0, b equals to 0, c equals to 0, should satisfy this one to be the member of the subspace given in option B. And if you put a b c d e f g all equal to 0, then you have 0 equals to 1. It means that uh, uh, b is also not our option. So now we check for C. Let us check C. For the same, I take the same again. Here in C you also see F. You see F again here. In all there is a symbol F. So I take the same. F equals to Fx and a1 x to the power 6 plus a2 x to the power 5, a3 x to the power 4 plus a2 x to the power 3 sorry, here will be a4 plus a5 x to the power 2 plus a6 x plus a7. Okay, so here it is given that f1 by 2, you know vector space V will have many members, and among those members you have to take those members which satisfy this relation, and from those members you have to make a subset. And here this option C says that that subset is a subspace. We have to check whether it is true or false. So if you use this one, f1 by 2 equals to f1, then our this will give us ai x to the power 7 minus I goes from 1 equals to 7, and here at the place of x there will be 1 by 2. So I change that one. Here will be 1 by 2. Okay, and this should be equals to I equals to 1 7 ai and ai 1 to the power 1 to the power anything is 1. So this is the relation. Okay, and since 0 is a member of any vector space, so this must be also the member of the subspace. If you equate this to 0, then ai will be 0 for all I equals to 1 2 and so on. So uh, if you put those values in it, then it satisfies the relation. So 0 lies in this set, but just checking the 0 member, you can't say that it is a subspace. So for the time being, I am leaving option C, because this question is a multiple choice question. If I prove option D wrong, then we will mark the option C as our correct option. So now I will go for option D. Option D. For option D, I take, here you see again F. So I keep the same symbol, and this time I take the coefficients as you see here, a5 x to the power 5 dot 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 a naught, or you may write here a1 x plus a naught. Okay, and here this time differentiation. So we have to first differentiate this one, then f dash x will be 6 a6 x to the power 5 5 a5 x to the power 4 plus dot 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 a1, and this should be equals to 1. Here it is given 1, you see here. So again the same, I mean you have to check whether 0 lies in this subspace or not. For that, if you equate this to 0, then ai will be 0 for all I. Okay, and when you put those values, this means, here I show you again, this means a1 a2 a3 a4 all will be 0, and if you put those values here in this, then this will be 0, this also will be 0 0, and this equals 1. Obviously it is wrong, so our option D is also wrong. So we are left with only one option, that is C. And earlier you saw that this option C has the 0 member. So our correct option is C. Okay.